All right. Difference quotient. The formula will be embedded into a problem like this if this appears on the final exam, so you don't need to worry about memorizing that difference quotient formula. The way it was always suggested is you start first with figuring out what is f of x plus h. So what I would always do is change that variable to an empty set of parentheses. So instead of 2x squared, it's 2 parentheses squared minus 2. And the parenthesis is filled in with whatever's in the parenthesis here. So if x plus h, you fill in with x plus h right there. There it goes. Okay. Oh, so much better. So 2x plus h squared minus 2. You're going to expand x plus h to the second power. I still see this every now and again. Remember, and I've said this before, you can't really distribute the exponent. You've got to multiply x plus h multiplied by x plus h times itself. So 2x plus h times x plus h minus 2. So the x plus h multiplied by x plus h is x squared plus 2xh plus h squared. Don't forget about that minus 2 at the end. And then distribute the 2. So all of this so far has just been to figure out what is f of x plus h. That's what goes on the top left of this big difference quotient, this fraction. Since you have that, that's what would go on the top left of the fraction. So all I've done is copied this result. This is f of x plus h. I've just written it up here on the top left. And then according to the rest of the formula, you subtract now the original function. And I've mentioned this also. When you're subtracting an entire expression, it's best to subtract that expression inside and put that expression inside of a parenthesis. So minus 2x squared minus 2. And then just divide by h. Because if you distribute the minus sign here, the 2x squared and this 2x squared would cancel. This, remember, is a plus 2 because you distribute the minus sign, so the plus 2 and the minus 2 would cancel. Any term that's left over after that, after you've canceled things in the numerator, any term that's left over should have h as one of its factors. 4xh and then 2h squared, they both have h as one of the factors. That's how you know you're on the right track. And since every term in the numerator has h as a factor, remember you can factor that out. Because then the h you factored out simplifies with the h in the denominator. And that's your final answer right there, 4x plus 2h. All right, time for questions. Like I said, this is only one type of problem from difference quotient. The difference quotient formula is always the same. It doesn't change. Go ahead.
That's okay. Are there anything, like any steps that go after you find the difference quotient? Like, does it apply to anything, or do you just need to find it?
It does apply to something not in Math 1050, though.
Okay. No, I mean, like, do we on the test, will we have to, like,
No.
do the difference quotient and then, like, graph it, or, like, do something else?
No.
With it? Okay.
You learn how to apply this really in calculus. If you
Okay,
go take
I didn't do it
calculus.
like that. I didn't,
Yeah.
like, up this test.
Math is important, dang it. Is that what you were saying? I know that. I'm just kidding. I'm just kidding. No. All of the question would be is find the difference quotient.
Okay.
What other questions do you have? Yeah.
Can we just write it like that, or should we do like f of x?
This would be,
equals- okay.
yeah, this would be fine. Okay, cool. The next two questions, these are from section, I think it's 2.6 when we talked about transformations of functions, 2.6. And I've only put two problems on here. One is a square root function, another one is a radical. It may be wise to go back and look at test questions from Unit 1, because we also graphed, what else did we graph? Parabolas that you had to transform, things raised to the third power. So just because you understand and can do these two problems doesn't necessarily mean you're 100% ready to answer questions on transformations for graphing. Does that make sense? So look in your homework, look on your test. Because all I've done here is a square root graph and an absolute value. It may be that it's something raised to the third power or something raised to the second power. So you need to be familiar with what all the different graphs look like. Or if it was a cube root, how would that change the shape of the graph? Those are all things to consider when you're thinking about this problem from 2.6. Okay? But for the two that we have here, use transformations to graph the given function. Like I said, not to beat a dead horse, but first and foremost, you need to have a picture in your head of what a square root graph looks like without any transformations. Okay? If you don't know what a square root graph or an absolute value graph looks like, then it's going to be hard to graph a graph with transformations. So those are called the parent functions. The parent function of a square root graph, I'll do two graphs here. One's the parent function. So y equals the square root of x. Remember, starts at 0, 0. So that's y equals the square root of x. If we graph one now that is negative square root of x plus 3 minus 1, what are the differences going to be? Well, plus 3, what do you remember? Well, it will go down. The minus 1 is going to move it down, yep. The plus 3 moves it to left 3. So let's talk about this. How do we know which one does what? Inside and outside. There you go. The plus 3 is inside because it's underneath the square root, and the minus 1 is outside because it's not underneath the square root. That's with square roots, and it's also kind of easy to spot inside and outside with absolute value. Obviously, the plus 2 is inside, the absolute value minus 4 is outside. What if it were a cubic function, meaning something raised to the third power? What would it look like to be inside the function versus outside the function? It really has to do with the exponent. So if it was f of x equals 3 times x minus 1 cubed, remember it's not necessarily always just a parenthesis. It's what's being cubed and what's not. How do we know the minus 1 is inside the function? It's not because it's necessarily inside the parenthesis. How do we know it's inside the function? Because it's part of what's being cubed, right? And then the plus 2 is not being cubed, so that would be outside the function. So those are all things to consider when you're thinking about what's inside versus outside a function. But we're all pretty confident to say that the plus 3 is inside the function. So that's going to move it left, right, or up or down? Left. If it were minus 3, it would move to the right. So that's going to move all of these points left 3 units. The minus 1 is outside. That's going to move it all down. So I would start with your starting point here. 0, 0 is going to move to the left 3 and down 1. So make a new starting point. Left 3, down 1. What else is happening as far as transformations? There's a reflection, yeah. What kind of reflection? If it's outside the function. Those are the two kinds. There's vertical and horizontal. Do you remember? If it's outside the function, just like this was outside of the function, the minus 1, how did it affect the graph? Horizontally or vertically? Vertically. So this is also outside the function, so it's also going to affect vertically. Anything outside the function affects it vertically. So this minus sign outside the function is a vertical transformation, or a vertical reflection, rather. So instead of going up, it's going to come down. Is it going to come down to the right or down to the left? Is it reflecting also horizontally? No. So it's just going to come down and to the right. Now, we need to be careful then on the exact shape of the graph. We can't just say it goes down and to the right. How can we get a few other points on here? We can plug them in. Now, I guess something you could also do, has there been any transformation that affected the width or the narrowness of this graph? Meaning, has there been a horizontal stretch or a compression or vertical stretch? So everything that's happened is just called static transformation. So we moved this point right here that I'm pointing at to the left 3 and down 1. Could we do the same thing to these 2 points, just move it to the left 3 and down 1? Careful. The answer is almost yes, but what else are we missing?
The reflection.
The reflection too. So if we took care of the reflection first and then moved it to the left 3 and down 1, where would that point be? Does that make sense? Like if this point that I'm pointing at was reflected over the x-axis, and then it moves 3 units and down 1. I guess you could do it that way rather than plugging in points. But plugging in points is probably a safer way. What point could we plug in for x? Or what value, rather, could we plug in for x? What do you think? You could plug in 1. Now, could you plug in anything you want for x? Let's talk about that. Any value for x? Could I plug in -10?
No,
Why not?
you can't have a negative.
Can't have negative. Right? And we know that the starting point is -3 and it's going to go to the right, so it can't be anything less than -3 based on how we graph it. So yeah, 1 would be a good choice because 1 plus 3, that's 4. Square root of 4 is 2. And then you times it by -1, so that's -2. And then -2 subtract 1 is -3. Now I can't remember what we plugged in.
One negative.
That's why I should write this down. We plugged in 1 and we got, so 1 comma -3 is on the graph. What about, let's see. What would be another good one?
Probably 3.
Now, even though 3 could work, that would give us the square root of 6, which is not a whole number. We would just have a decimal, which is fine. If you have a calculator, you can do a decimal. What about -2? I know, our first thought probably isn't negative values, but why would -2 be such a good choice here? Because you just get square root of 1. So let's try -2, huh? -2 plus 3 is 1. The square root of 1, 1 times -1 is -1. And then -1 subtract 1 is -2. So if you plug in -2, we got -2. So there's 3 points. All you need are 3 points on that graph. And there you go. Now, it wasn't included here, but it may be on a final exam. What would you then say is the domain of the transformed graph? What would you say the domain there is? Okay, now you're correct. Bracket or parenthesis? Bracket, good. What would you say is the range? We're thinking y-axis now. Are any of these values on the y-axis in the range? What's the highest value in the range? So that's the number that goes on the right. What's your bottom limit? Negative infinity. So it goes negative infinity up to -1 with a bracket. Okay, good. All right. Gosh, I covered up question B. Can you still see it? It's -3. It says -3 times the absolute value of x plus 2. I mean, pretty much it's the same thing. It's just a different shape of the graph. What's the absolute value graph looking like?
V.
It's a V. This one's going to be facing up or facing down? Facing down. And then is it going to be wide or narrow? Because of that 3. Well, let's see. Maybe we're going to have to decide now. Let's see what the graph looks like. So the normal absolute value with no transformations, just y equals the absolute value of x, has a vertex at 0, 0, and a slope of 1 going in that direction, a slope of -1 going in this direction. So there's absolute value of x. What we need to do now is, with transformations, what happens? Left 2, down 4. So that's our vertex. This point here in the middle is going to go to the left 2 and down 4. Like that. And we know it's going to be facing upside down. And then we haven't quite decided yet what the 3 does, but it is outside the function, right? So is that a vertical change or a horizontal change? It's a stretch or compression because it's multiplying and not adding. It's vertical, and it ends up being a vertical stretch. If it's outside the function, anything bigger than 1 is a stretch. So essentially what it means is instead of having a slope of 1 and a slope of -1, what do you suppose will be the slope? Something to think about as we maybe let's plot some points and it'll become more apparent what the slope is. So what can I plug in for x? What values? anything now, because there is no restriction on absolute values. You can plug in anything you want for x. The domain is all real numbers. So probably wouldn't be a bad idea, though, to stick pretty close to where our vertex is. Our vertex is at -2. So what if we just went over 1 and plugged in -1? Hang with me here for a second. Plug in -1. -1 plus 2 is 1. Absolute value of 1 is 1. But then 1 times -3 is -3. And then -3 minus 4 is -7. So when I plugged in -1, we got -7 out of that. -1, 7 is down here. And that also means, based on symmetry, that -3, 7 is on the graph. So what did the 3 do to the graph? The negative sign flipped it upside down. What did the 3 do to it? Stretched it vertically. Yeah. There you would say the domain, all real numbers, -infinity to infinity. And the range, -infinity up to -4 with a bracket. Yep. Never a bad idea when you're graphing anything on these reviews to consider what the domain and range would be, because they could always ask that along with something, along with graphing. I think that's it for that page. So let's talk about what could be different from this learning target. Use transformations to graph the given function. They could switch this around and give you a graph and ask you to come up with what the equation would have been. Does that make sense? So if this is what the graph looks like, it may be that you have to write the function. So just something to consider. All right. Ooh, the fun one. Inverses. This is from section 2.8. Inverses were from section 2.8. We talked about a function being 1-to-1. All that means is if a function is 1-to-1, remember that it has an inverse that is also a function. Write an equation of the inverse of the function. Now, this was, especially this one here, this was a bonus question on our last exam, exam 4. And a lot of you knew what the first step was. You switched the place of x and y. So it's good we're reviewing this, because then it got a little fuzzy after that, after what to do next. And I just threw on a bunch of different types of functions, because you never know. All it says is you gotta be able to find the inverse of a function. So you gotta be prepared for any kind of these. These are linear, this is a linear function, this is a cubic, and then we have some rational functions. So step 1, find the inverse. Remind me what it is? Yep, switch the place of x and y. Remember, f of x is just y. So you switch the place of x and y. And then solve for y. Yeah, pretty straightforward on finding the inverse. Now, part A and B, more straightforward so than C and D. There's more steps involved in C and D. But now that you solve for y, you just got to follow order of operations, or I guess reverse order of operations. Subtract the 4, and then divide by -5, and you're good to go. And then divide by -5. And it is very clear on the grading rubric, I suppose, for questions like this, that you will miss a point if you don't denote your final result as the inverse using the correct mathematical terminology. This has to be shown on your answer, that f inverse of x, otherwise you miss 1 point. Like that. You don't have to put the y equals, I just put it in there. Okay, part B is just pretty much the same. You switch the f of x, you make it an x, and then the x right here, you make that a y. And solve for y. Do you cube root now? Cube root's your last step here. You want to get y cubed alone, then cube root. So you got to divide by 4. cube root is a final result. So your inverse will be that. So again, first step, switch the place of x and y. And I've asked this question a bunch. Do we want to solve an equation with or without fractions?
Without.
Boo on fractions, right? No fractions. We hate fractions. So how do we clear the fraction?
Multiply by the denominator.
Yeah, multiply both sides by the denominator. So multiply this by the denominator on both sides. That clears out your denominator. So now what we have is 5 equals, do we distribute now? Let's see. Let me write it without being distributed. So the x is in front of the parenthesis, negative y plus 2. What is it we're solving for at this point, once we've cleared the fraction?
Why?
We're trying to get y by itself, yeah. We could divide by x. What are the options here? We have a parenthesis. We could distribute the x, or we could divide by it. Let's divide by it, see what it looks like. So if we divide both sides by x, that's going to give us 5 divided by x equals the opposite of y plus 2. Okay, not so bad, not so bad. Okay, subtract 2. What does that look like to subtract 2? I mean, I know what it looks like over here. It's just going to cancel the 2, but
It'd be opposite.
it would be 5 over x
Minus.
and then the minus 2. You can't minus the 2 from the 5 or minus the 2 from the x. It's just 5 over x as an expression and then the minus 2 after it. So 5 over x minus 2 equals the opposite of y. And then divide by negative 1 here. We're going to divide by negative 1 there. What about on the other side? Yeah, I mean, if you want to go the easy route, it's divide the whole thing, but you're not going to write it like that. You do divide everything by negative 1, but when you divide terms by negative 1, you're just changing the sign to negative. So really what that means is this becomes negative 5 over x, and this becomes positive 2. So we have negative 5 over x plus 2 equals the inverse of f. I'm curious, and it's okay if you didn't do it this way. Did anybody distribute the x after?
I did, but then I just took out the x. So it's,
But you went back and did it this way?
I took it back, I factored it out.
Let me-
I didn't even realize that I did that until you went over it.
Okay, let me show you what the answer would, because your answer is going to look different if you distribute the x, but it's the same result, just in a different form. So if you were to distribute the x, it would be 5 equals negative y x plus 2x. Remind me again, what is it we're solving for? Y. The point is to get y all by itself. This term does not have a y, so I'm going to move it over here by subtracting, leaving the only term here is negative yx. So I'm going to subtract the 2x over. So that would be 5 minus 2x equals negative y times x. And then you would divide by negative x. So then you'd have 5 minus 2x divided by negative x. And that equals y, or the inverse. So that's also a correct version of the answer. It looks different. How would you get from here to here?
Oh, the x's cancel out, so doesn't that come out of the expression? Like, can you do the...
Well, the x, if this had an x with it also, then you could factor an x out of both of them. But if I were to combine this into one expression by adding fractions, guess what it would be? That. Okay, so really there's just two different ways of writing the same thing. Either one's acceptable. Okay, not a problem like that. Okay, this one, more along the lines of part C, maybe a few extra steps. So we're still going to switch the place of x and y. The difference is now we have two y's to account for. We have y minus 5 and y plus 1 in the denominator. But it's still the same old problem. We don't like fractions. So we're going to multiply by y plus 1. Now, we have y plus 1 times x equals y minus 5. Okay, what do you think? What is it we're solving for again?
Why?
So the problem here is there's two y's. Part C was a little easier because there was only a single y to worry about. Now we have a y on this side of the equation, we have a y on that side. And that's never going to work. If you're trying to solve for a specific variable and they're on both sides of the equation, that's not going to work. So what do you think our task should be? Get them all on the same side. All the variables you're trying to solve for, get them on the same side. Any term that does not have that variable, get it on the other side. It'll be a little tricky if we have this parenthesis here because we can't do anything to this y as long as the parentheses is there. And let's talk about this. We could divide by the x again, but then that presents a problem. If y minus 5 is being divided by x, then you couldn't move the 5 over because it's being divided by x. Does that make sense?
So distribute.
So in this particular instance where we have y's on both sides, it would make more sense to distribute the x. So distribute the x and you get yx plus 1x, or simply x equals y minus 5. Now we can just move terms around from one side of the equation to the other because nothing's being divided really and nothing's being multiplied. So this y right here needs to move. Either you move this yx over here or you move this y. It really doesn't matter. Just move them. So any way you do it, the y's need to be on the same side, and any term that doesn't have a y needs to be on the opposite side. Just to be consistent, I always move the y terms to the left side and the non-y terms to the right side, but that's just me. So I'm going to subtract this y over here and then subtract this x over here like that. So cancel the y, cancel the x. So I get yx minus y equals the opposite of x minus 5. And I know we've seen a bunch of problems like this so far. We've done a few. The whole reason for getting all the y terms on the same side is now it is a common factor, and if it's a common factor, you factor it out. So you factor out a y, leaving x minus 1. And by the way, if you had moved terms opposite to what I did, if you moved the yx over to here and then added the 5 over here, your answer is going to be the same, but everything's going to be opposite, if that makes sense. Like your fraction is going to be the same, but it's going to be x plus 5 over 1 minus x. But it's the same thing. The last step is just divide by x minus 1. So your inverse is that. Yeah. This is also from 2.8. The graph of a function is given. Determine if it has an inverse. We haven't talked about this for a while. Determine if it has an inverse. So these are two different problems. We have part A, and this is a separate problem. Part B, the B left off of it for some reason. But so let's just look at part A. How do we determine if it has an inverse? Well, if it's 1-to-1. A vertical line test is testing for what? If I'm drawing vertical lines here, what am I testing for? If it's a function. Now, they've already told us it's a function, but it passes the vertical line test. What was the other test we could perform? Horizontal line test is testing for 1-to-1. And I just mentioned this a few minutes ago. What does it mean to be 1-to-1 function? It has an inverse that's a function. So really what they're saying, determine if it has an inverse, does it pass the horizontal line test? Well, does part A pass the horizontal line test? Yeah. So it has an inverse that's a function. If yes, then sketch the inverse function. Well, this is actually easier than number 3, because it's only really that first step. What was the first step in finding an inverse?
Switch X and Y.
Switch x and y. That's all we're doing here is switching x and y. Graphically, finding an inverse is way easier. So what you would want to do is identify some key points, like the points that go through an exact corner where you can find actual whole number values. Like all of these that I'm highlighting are points that have whole number values. So if this were me, just because I don't want to make any silly errors, I would write them down. So I've got a point at -3, comma, what is that? -3, comma, -3. I've got another one at -2, comma, -1. I've got another one at, let's see, what is that one right there? -1, comma, 1. This one here is 1, comma, 2. And then 4, comma, 3. So those are points that are all contained on the original function. The inverse just switch all the places of x and y. Nothing happens to that first point, but everything else. Should have done that in a different color. So there's your inverse. And you probably don't remember, but an inverse and its function are always a reflection across this line, y equals x. So if you were to graph that line, y equals x, then the original function and the inverse should always be a reflection across that line. So part B's, well, is it the same? Does it have an inverse? Is it 1-to-1?
Yes.
Yeah, so it has an inverse. If yes, sketch the inverse. So same thing. Identify points that have, be easier to do, easier if you do whole number values like that one, maybe that one there. Even that one, we could say that's -2, comma, 0.5 maybe. Wait a minute. I made a mistake here. The scale on this is way off. That's actually -1, comma, oh man, all right. I guess that's something to pay attention to then, because they may throw that at you. So this point is actually -1, comma, well, you know what? Then that means that this is 0.25, isn't it?
Yeah.
-2, comma, 0.25. Boy, that's a mean trick. And then this would be -1, comma, 0.5. And then we have 0, comma, 1. There we go. And then 1, comma, 2. And then 2, comma, 4. So then you would switch the place of x and y. So 0.25. -2 is going to be right about there. 0.5 comma negative 1, 1 comma 0, 2 comma 1. There we go. Well, I don't know why that had to be so hard. That's a pretty easy problem.